Howdy everybody in YouTube land. We've done got off the crazy deep end here. So what we have in front of us today, if you don't already recognize it, is we have some SE30 logic boards, motherboards here. But the problem is these motherboards are battery bombed. This one, if you noticed, I've been using them for parts over the last 10 or so years, but I figured I might as well do something a little more with them because what I have on hand is this guy here. Now, this is an SE30 reproduction board. Now, I bought this board a while back. This was the pre-release version. This is not the public version. There's been some tweaks and changes to the one that you can get now because the Gerbers are open source for non-commercial use only, but this one predates that. This is the older one. So, but there shouldn't be any differences, or at least enough differences to where it won't work. But hopefully, between these three boards, I can make something work. This particular board here is the worst one of the bunch. I just got done with white vinegar to try to neutralize the acid and then cleaned it off with water. But this is the worst one. This one might not be salvageable because the chip is just eaten beyond all usability. So this one might be parts for other chips, but right now they're pretty much, it's pretty much done. So I think what I'm going to do is clean the rest of these boards up and start pulling off parts to start populating this board. Scrub a dub dub, cleaning up all the acid and neutralize it because we don't need all that fun crap to happen. A little bit of bake drying. Not like it matters a whole lot, but you know. So while that's drying, I want to go through a few things here. So this particular board, there's been some changes to make it more adaptable to modern times. For example, coin cell battery instead of the big barrel battery that was here. So that was actually a smart move. And also onboard flash memory versus the original ROM socket. Now, I think you can still get that socket. Don't quote me on that. I'm not sure. But on mine, all of them are bad. So, not going to do me any good. Now, what I can do is I went ahead and bought some of these sockets from PE Connectors. So, I'll put those in. And what I'll do is I'll use the Rominator image to run this board. So since this is a reloaded board, not original anyways, we might as well just max it out with the Rominator and all that fun stuff, because why not? So I have that. I have the new Sony chips from UT Source. I have those. Now that leaves the RAM sockets. So now these RAM sockets, apparently the spacing is too narrow on those, so they won't fit in here. But I think I can actually, no, I can't. That won't work. Yeah, so this was a big waste of money, but I was hoping I could snap them apart, but I can't. Unfortunately, they're too wide, so that's not going to work. However, these should be able to work, but I don't think those pins will fit through those holes. It's a different spot. Now, the ones that originally went in here, you can't get them anymore. So, unless I pull them off the original boards, I'm going to have to settle with something like this. So, that is, again, from Phoenix Enterprises. I got 8 of them, so I can build one board. That's my goal, is to build at least one functional board. So, I got those. I bought these just in case they would work, but unfortunately I don't think they're going to. Oh well. So what would be cool is if this design was revised even more to put 72-pin SIM here. You could get away with like 2 SIM modules. Anyways. Alright, so I have that. I have the... I think this is the Swim chip. No, 85C30. That's one of these. One of these two. I mean, one's a 53C80, the other's 85C30, something like that. So I have that. I have the PGA sockets, again, from the same place, PE connectors. So I can put that in here for the processor. Let's see. This is the video memory from UT Source. QR code if you want to scan it. We'll go in here. So we'll install that. Then I have the real-time clocks for this here. Got 4 of those, 5 of those. Actually, it says I paid for 5. No, never mind, 4 pieces. Never mind. This is the chip that goes here, because they occasionally get damaged. No, never mind. That's not right. This is a 26LS. That's for these. That's for these two here. So that's for those. There's all of my repair parts for working on SC30. So I have all those. I have my 166. I've got some 74F258s, and you can tell I've had that for a while. So that will be used to replace these. So we're there. And then this guy, the 29F040, which is what goes here. Now, the ROM has to be prepared a certain way to make this work. And I think that was one of the problems with this revision of the board, is the data bits 0 through 7 are backwards. So 7 is 0, 6 is 1, 5 is 2, blah, blah, blah. So in order for the ROM to work on this board, not only does it have to be split in 4, it also has to be bit flipped. So, but that's not a big deal. Just gotta pay attention to that. So that's my cache of new parts. Now I might need more. I don't know yet until I dig into this, but I might need more. For example, I might need some parts that are over here. Probably not, but I might. Also, the issue might come here with these resistor packs. I don't know if they're still good on mine or not. Between the 4 boards, I should be able to build one. The PALs, if you saw on my other boards, some of them are missing, and that's because I've had to use them to fix other boards in the past. But between them all, I should have enough. But if not, the good news is the person who created this, the project, is available. The JED files for programming new ones of these are available. So the GALs, the AT, the Atmel versions, I think you can still buy new, will fit here. That is a big wild card. That's a big, I don't know. Anyways, ADB chip. I don't know if I have any of those on hand, but I do have them on the board. There is ADB power, PFW. Not sure why this is routed out. I think this is routed out because Doug or Bob Braun or something, made an extension so you can actually wire this up to soft power. So when you go to special shutdown, it will turn one of these lines low. So if you had a soft start power supply, you could press the power key or turn this thing on and off using the, that method. But it takes some hacks to get it to work. Anyway, so that's the top side. Now the bottom side, now a lot of this has changed. Reverse engineered PLD code available. Thanks to everyone from 68K for supporting the creation of this board. So there you go. Now this has changed since then. It doesn't have the same inscriptions on it, but this is an unreleased version, I think. I ordered this before it was released. So, all right. Now we just need to start picking parts off of the old boards and placing them on this one. First order of business, though, I think, is I want to do all the bird seed on the backside. So all of these transistors, capacitors, all that stuff. It's going to be a pain because a large number of them, but they're all intact on the other board, so I'm just going to move them over to this one. And then once I do the bottom side, that's when I want to start doing all of the big PLCC chips and stuff on the top side. And get the rest of the surface mount load on the top, then work on the through hole. I think I'm going to do the bare minimum load first to see if I get anything out of the board. Alright, now that we got all the boards dried out, we can triage these things to see what's salvageable and what's not. So let's look at the one that's right in front of us. Now, this one might be the worst one of the bunch. That chip there is probably not salvageable. Let me see if I have a pick tool to pull this out. So, yeah, it's not salvageable, I don't think. Now, CPU might be. This chip here is probably not. I have 3 of the pals, 2 are missing. They look to be in good shape. These 2 are here in good shape. Let's see. Oh, that one might be okay. This one's questionable. This one's questionable. Both of these are probably junk. This one's probably gone. These 2, that one might not be good. This one might be okay. That one's questionable, but it might be alright. These 2 are okay. That one's okay. Mostly. Fuse. That's not salvageable. That's not salvageable. Yeah, nope. Not salvageable. That's definitely not salvageable. None of these are. These, no, probably not. I'm likely going to need to order those. These 2 are definitely not salvageable. So, the RAM sockets look like they might be salvageable. I don't see any corrosion. I don't see any broken tabs. So, I could probably save those. The rear, the rear thingy is not salvageable. This is probably junk. So I can save some stuff on this board, but not everything. Now this board here is in a lot better shape. This is probably salvageable. Not bad. This is probably salvageable. My pals are missing. They were probably stolen, so these are not. These 2 are there, but maybe between these 3 and these 2, I have something I can use. So I have those 2, I have those. That looks okay. This one's a little rough. One's a little rough. Oh, these are salvageable. These are salvageable. These are not. And I wouldn't save those anyways. So I have those now. See, the coprocessor looks salvageable. The glue looks salvageable. All those are all fine. Well, this one might not be. I don't know. There's a little bit of green crusties. But they might be okay. These are green, so I don't know. These are not salvageable. No, these are not salvageable. But these might be. So that's not. These are okay. These are okay. So the connector, that looks salvageable. That's not salvageable. So we'll move that out of the way. Oh, and the rear guard's salvageable, so I'll save that. So between those 2 boards, now we look at this one. Let's see, what do we have here? That's probably not salvageable. That's not salvageable. One of these might be. These are not. That one's okay. This one has all the pals. One RAM missing, but it has all the pals, so that's salvageable. Oscillator's there. The glue is there. That might be okay. These are okay. That's okay. That, no, maybe not. That's okay. That's okay. These two are okay. Most of these are okay, except for this one, which is normal. Yeah. So between these three boards, let's see, what's the RAM socket? RAM sockets are good. Oh yeah, that looks good. So yeah, between these three boards, I can make one good board. So I'm already good here. Now let's take a look at this one. ROM's missing already. That's not salvageable. That's not salvageable. That's not. So none of the real time clocks are salvageable. Okay, that looks good. Maybe okay. I already borrowed that. Those two are good. That one, not so much. Questionable. Those two are probably fine. These are fine. Oh, these all look salvageable. So yeah, I got all my pals. I got video circuits. There's that. Glue. Let's see. Nope, these are junk. Those are junk. These are all junk, so no, that's junk. Let's see. That one. Ugh. No, not really. The reason why I say this is because the pins being bad, there could be infiltration into the epoxy, so that's why. So between these four boards, I should have something that's usable. So at this point, it's a matter of, I think what I want to do, that's screwed. There we go. I think what I want to do is I want to start taking the parts off and moving them over to the replacement board. The ports are good on this one, so I can steal those. Yeah, I think I'm okay here. I think we can make one good board. Maybe two, but that's pushing it. Alright, so pretty much a wash, rinse, repeat here. So I've got these moved over, that capacitor there, and I've got all of these parts here moved over. So now I've got the rest of these I gotta go over. This is all screwed, so I can't use those. I'll have to pull them from somewhere else. But yeah, everything from here, besides these, all of these have to get moved over still. But yeah, it's done. I mean, you gotta be careful. I've noticed here, there's some slight differences in where these components are placed, which is not that big of a deal. But perhaps more importantly, and the reason why I want to point this out, is there are components that are extremely close to vias. Vias are way too close. I'm trying to find it. Like this one. The vias are so close. So if you're not careful and you fat finger this trying to solder it, you'll blob over to a via and it's not going to work. So you've got to be super careful when you're laying this out compared to this. The vias are kind of spread apart. It's not like that on that. And the reason why is this is a 6-layer board. The recreation is down to a 4-layer board to keep it cheap and simple. So be careful and take note of that. As I'm going along here, there's a couple of things that I want to make a note. So number one, R40 through 43, these 4 resistors, they are not on this board. And from what I understand, they are not necessary, so they were not included on this design, so these will be skipped. Also, on the speaker jack here, there's 2 little jumpers here that's not on the original board. Now, that is designed to put a solder jumper here if you don't want to put a speaker jack in place and you want to test the board, or if you want to exclude the jack from ever needing one, then you would need to jump that so the internal speaker would work. So I just wanted to make those 2 notes. Alrighty then, so all of the passives are on here except for, once again, we have R38, 37, 36, which are not used on this board. So we have that set over here, and we have that set over there. So those aren't used. Now, unfortunately, a couple of these were just corroded beyond usability, so I had to steal them off of this other board here. So I got that one I stole. Also, I need to grab these 2 resistors because those are just too far gone. So once I do that, the bottom side of this board's done. And then we can move on to the chips. And what I want to do is I want to grab the best chips out of the bunch, clean them up, and bake them so I can drive the moisture out of those chips. Because I want this board to last as long as it possibly can, and epoxy will absorb moisture over time. So I want to drive all of that out. Matter of fact, it's actually standard operating procedure when you're assembling a board at the factory, is to bake the chips if they're exposed to moisture too long. So I want to bake the chips and then reinstall those chips into this board. So first off, let's get the passives done and we'll move on to that. I have the bottom side load done. You're probably asking and wondering why don't I just buy all these parts new and have that assembled on with new parts? I mean, I certainly could. There's nothing wrong with that, but I figured I wanted to challenge myself because I'm curious how cheaply I can make one of these boards and be able to reuse as many parts as I possibly can off of the old board. So all of the passives are already on here, so I might as well just use them. But certainly I could buy all new logic chips and all new passive components and all that stuff, with the exception of the Apple Silicon. Certainly, no problems, and some people can do that. And it might actually increase the reliability of it. But I just wanted to see how much of it I can reuse and how to do it as cheaply as I possibly can, because why not? Stuff's getting expensive now. In the process of pulling the chips off the top side of the old board now, and this is definitely a process because I moved that out of the way and I moved that out of the way just so I wouldn't melt them pulling those. So I got those. That one I already melted from when I pulled this who knows how long ago. So the only thing left now is I got to pull these two. I got to pull the processor and I got to pull this chip here. It's just a matter of seeing if I want to pull these or not because of how bad they actually are. I definitely want to save those. And I'm trying to save these, but it's become fun because they've got all, I've pre-fluxed it, pre-soldered it. I got one. But the issue is they've folded all the leads over. So yeah, what I've been doing is while I've had my desoldering iron, just to try to help with the thermal mass, I'm actually using the heat gun here, this little hot air tool, and I'm warming the board as I'm desoldering it. That way it makes it easier to pull it out. It made quick work of the SCSI connector because it's on this ground plane too. So it's actually working quite well, that technique. Now, there was a couple of bent pins here I tried to correct. I tried to pull this one by hand and it's like, no. So I think I'm going to have to take the heat gun to this one, the non-temperature controlled one, which is dangerous, to heat this up and just pull it from the other side. It's going to be a lot easier to do it that way. Getting this metal bracket off, which this is the garbage one, so I'm not going to do that one. But to get that metal bracket off, not going to be fun. So, yeah, it's coming along. These poly fuses, I removed them and they're starting to fall apart on me. So, got to be careful with that. Alright, now, besides this chip here, maybe a couple of things back here, I pretty much pulled everything off of this board that I could possibly use. The only thing I left behind is the junk. Like, that's all garbage. All of that stuff's eaten out, rotted out, baked. Same thing over here. It's just junk. And those three chips there, especially UE8, it's problematic. You can see the corrosion and stuff there, so I'm not going to save those. I did save those, but none of those. So, I got all the through-hole parts out, which was painful, but I got it out because the leads were folded over. And I practiced on the Sony chips. I didn't even unsolder those with a gun. What I did was just heat it up and pulled them out, and you can see where the pins are splayed out. So, anyways, that's done. So really, I can set this board aside. Besides, I want to remove that. And I'm going to use the big beefy heat gun to do that. But I'm going to remove that, and I think that's going to be it for this board. I might practice removing these, even though they're junk. I might practice removing those with a heat gun to see if I can pull them out. So, yeah. I had to move to another board to get the rest of the parts I needed. Like, I had to pull that. I had to get another one of these. I had to pull these two connectors, and one of them over here, they're over there. Had to get that connector and that chip, along with these 3 filter networks. Oh, and these 2 as well. So, I pulled these 3. I don't know if they're any good or not, but I still need another one of those 201s. So I need to go yet another board and go get another one of those. Yeah, so slowly but surely. I also removed the rear metal plate, which I cleaned up. It's here. So I have that now too. Set this off to the side. All right. Okay. At this point, it's a matter of assembling the other board. One chip at a time. Alright. I have just about everything I need. There's some extra stuff I'm going to have to buy, but to get the board tested, I don't necessarily need them right now. But the next part of this task is to get all of this in there. So I think what I want to start with is I'm going to start with these big PLCC chips first, just to get them out of the way. Now, the coprocessor is going to be questionable because I had to clean these up because there was some battery damage on the edge of this chip, and I do not know if this chip is any good. And it may not be. So if I know it's not good, I'm not going to populate these 4 SIM sockets until last. That way I can get to this easier. The way I'm going to do this is there's 50,000 different ways to do it, but the way I'm going to do it is I'm going to use this 835 rosin flux, and then this paintbrush I got here, this cheapo. I'm going to use that, and I'm just going to whisk some flux on the pads and the chip, and I'm going to solder it in. That is how we're going to do this. Now that we got the first chip on, we can kind of see what's happening here. Now when you do these, you have to be careful because sometimes it'll look like it's soldered, but it didn't really actually solder to the pad on the bottom. So always double check your work. Make sure you don't have any shorts and that you're actually soldered to the bottom. So in this case, it looks like we are. Because what can happen is if you don't pay close attention, when you go to fire it up, it doesn't work, and be like, oh man, it doesn't work. Maybe I got a bad chip. No, you got to pay attention to how you solder these. Obviously, you don't want to bridge it, and just use best practices, basically, what works for you. I got all of the PLCC chips in, but there's a couple things we need to note. Most of them can be soldered in by hand from the side fairly easily, except for this one. This one, the pads are up underneath, so you can't really get that in well. So you kind of have to work at it and work at it and work at it, or pre-tin all the pads and then reflow solder it in place. And then these two are the same problem. The footprint won't get, you can't get in there with a soldering iron. So what I had to do was get some flux on there, kind of build up solder a little bit on all the pads, and then reflux it, put the chip on, and then reflow solder it in with the hot air tool. I had to do that to both of these. And then I went back around with this. That's why it's so messy. So, yeah, that's all done now. But, man, that was a pain. It's all good. Now I just have to get that one in. And this is going to be the same problem as this one. So I'm going to have to pre-tin those and reflow solder it in. There are some new ICs that I have, which are this one here. These are the 74F258s, which go here. And the reason why those are new is because these, not only do they get blown by the battery, but these chips almost always go bad. So, new ones for those. Alright, so now that all of the chips are installed, all of the surface mount chips anyways, I gotta do these 3 poly fuses, and then after that, it's time to start getting the through-hole parts on. Now, I can't do anything with these yet because I don't have them. Same thing over here. But I can start getting the through-hole parts on. At least most of them. Now that I have all of the integrated circuits in here, except for a couple here and here, which I don't have right now, but now that I have everything else installed, I can go ahead and give this thing an acetone bath to clean all the flux off. I didn't want to do that with all the other plasticky bits on there because I didn't want it attacking the plastic. So that's what I'm going to do next. You get the idea. Just like that, the board is clean. I even got the back side done too. So now it's a matter of soldering the rest of the parts in and then cleaning those by hand. And there we have it. Everything's in there. Everything needed to make it chime anyways. Well, I still got to put that in, but for now, I wonder if I can get the ROMs programmed and get them seated in there. And hopefully this thing will chime and produce some kind of a video signal. Wouldn't that be something? Who knows how long this board's been dead? We're finally in a position, I think, to where we could potentially test this thing. I hope. So, yeah. Can't do the SCSI, the floppy, or any of that yet because I just want to see if this thing chimes and produces some kind of video. So, man, brand new SIM sockets are tight. You only need the first 4 for testing because they're not important for what we're doing. Damn. There we go. It's really hard to get in there. Alright, so I don't have the speaker amplifier in here yet, so I'm going to use headphones to see if I get a chime, but whew, well, it's now or never, so let's get it hooked up. Alright, so the board's in there. I'm going to get the power in. I've already done a quick inspection. It's either going to work or it's going to blow up. I need to be able to see what happens though. No boom booms. Holy crap, it works. Oh my god, it works. First try. Wow. I probably won't get a mouse cursor because I don't have the real time clock chip in there, but hey, the CPU's executing code. Alright, now we're getting somewhere, so I'm going to start putting the rest of the parts in now. Whoo, yes. Alright, tapping the reset button, courtesy of jumping out that because I don't have any buttons. Boom. I got something. Now the audio sounds very distorted. So that makes me wonder, I probably have a bad connection or something. Or the Apple sound chip is bad. I mean, yeah, these chips came off of a battery bombed board. So really, it's a wild card. But this is not bad for a first try. Holy crap. We're getting somewhere. I took the board back out so I can inspect it. I got the ROMs in there, RAMs in there. It's intermittent, like it'll go gray screen. If I reset, it'll boot, and the audio's distorted. But first thing I see right away is, guess what I forgot to solder to the board? I forgot to solder that side of the damn sound chip. Other sides are good, everything else is good, but that one, whoops, well, that'll do it. Now that I actually resoldered the side of that chip, let's try again to see if we have sound, which I gotta position the camera where my headphones are, which is going to be in the view of the camera, but why not? Because I don't have the speaker figured out yet. So power switch, yay. See if it actually completes a full reset. Yep, it does. Alright, good enough. So now we can move on. So I can get the rest of the SIM sockets installed. I can get all the ports installed. Get all of that done so we can finish this board. Oh, yeah, I'm going to have to order a Eurodin socket. I don't have that either. There's a few things I'm going to have to order. But the goal of this video was to see how much parts I could actually reuse. And turns out I was able to reuse enough to get it to work. One more thing I need to make a note, because I'm putting these ports on. The side tabs that are on these jacks do not fit through these holes. So for example, those are the size of the holes there. Well, they need to be that size, because if you look at the jack, see those wide tabs? No, that's not the case here. So this board must have been designed for brand new jacks that are current production. So the original ones won't fit in there. So we got to clip them off, and I'm soldering them from the top. Like I'm just, just soldering on the shield, and just so they don't come off. And now we have the I/O ports installed. So I almost don't want to put these RAM sockets in until I run a program to test the FPU to make sure it's actually still good. Once I know it is, then I'll solder that in, because otherwise it's monumentally more difficult to remove this without damaging the sockets with the hot air tool. So I'll do that last, these sockets. But in the meantime, I got the I/O ports installed, I got the connectors installed, and I got the mounting plate installed. So we're good now.